Okay, this is problem 622, the problem that we sketch in class today, and we are going to go through the detailed solution right now. So the problem is what you're asked is to find the forces on each one of the members on this truss here and state whether they are in tension or compression. So the first thing we need to do is find the reactions. We might not need to find them all. In fact, we only need to find C because if we find the reaction in C, then we can solve for these two members. Then using D, we can solve for these two members. Then using that, we can solve for these two members. And then finally, we can solve for these two members. So we might not never need to find A. So let's just draw a free body diagram for the truss. For the whole truss, this is the free body diagram here. And then we have a force Cy right here. Then we have a load here, which is 600. Then we have another load here, which is 400. And finally, we have two forces here, Ax and Ay. So to find this force Cy, we write the moments about A. The moments about A said that, well, you get minus 400, the moment produced by this load here, and that is at a distance of 1 meter from A times Y times 1, minus 600, right? Those are both negative times, and this is at a distance 3 from A times 3 here, and let's just write that properly, times 3 plus Cy times what? Times this whole distance, which is 4, that is equal to 0. Solving for that equation, we get that Cy is equal to 550 newtons. So now I know Cy, and I'll see if I need this later on, but with Cy, I can go ahead and work on this joint and see what I get. So let's just work on joint C. The free body diagram for joint C would be, this is C, so you get Cy, the normal force, then you get FCV, and this is the force on this member, and finally you get FCD, and that's the force on this member. So if I draw this force this way, then that means the force on the pin is this force here. Therefore, the force on the member is the other way, and that member would be in tension. So when I solve my equations, if I get a positive sign for this, that means this member was in tension. If I get a negative sign, that means this member was in compression. So let's just write the equations now. So I get for the x-axis, I'm going to get that FCD cosine of 45 degrees minus FCV, that is equal to 0. For the y-axis, I get that Cy minus FCD sine of 45 degrees, that is equal to 0. And I'm using this angle here, right? This is 45 degrees. All right. So now I can go ahead and solve for these two. And if I do that, I get that FCD, that is equal to 778 newtons, and is positive. So my initial assumption was right. And that member is in compression. And then I have the other one, which is FCV, and I get that that is equal to 550 newtons, and that is also positive. So that means that member was in tension. Okay, so now let's go. We have the forces on these two members, and we have the reaction. So let's use this joint to find the forces on these two members here. So joint D, And let's draw the free body diagram for D. For D, what do we have? Well, we have first the load, 600 newtons. Then we have a force coming from this member, FDE, and we are going to draw that as compression. And there's no reason for that. I mean, I'm just choosing one. You can choose the other one, and remember, there's just going to be a minus or plus sign there. Then you get this force here. This is FCD. And then you get this force here, and this is FDB. FDB. So our aim with this is to find these two members, so we can write the equations of equilibrium for that. And let's do that here. Let's just move this here. So the equation of equilibrium, and this goes this way here, just to the equations of equilibrium for the x-axis, what do I get? For the x-axis, I get that FDE plus FDB cosine of 45 degrees minus FCD cosine of 45 degrees, that is equal to 0. For the y-axis, what do I get? I get that FCD sine of 45 degrees plus FDB sine of 45 degrees minus 600, that is equal to 0. Okay, and therefore that is my solution. And now I can go ahead and solve for these two. And if I do that, I get that FDB that is equal to 70.7 newtons, and that'll be in compression. And FDE, that'll be equal to 500 newtons, and that also will be in compression. These two are in compression. Why? Well, FDE is the force on the pin. I drew it pointing out, right? FDE. This is the force on the pin. So therefore, the force on the member is the reaction to that. It's a force compressing the member the other way. So that's why this is in compression. And also, I didn't get a minus here, so it was either in compression, and same reasoning for this. So now we have the forces on these two members and these two members. So we need the forces on these three members. So we can use E to find these two members. Let's do E. And then E, we can draw the free body diagram for that. And then I have here, this is 400 newtons, right? The load. And then I would have, what else? I have FDE coming this way. Then I have FEA coming this way. This is FEA. And also I'm going to have FEB, which is this force here. FEB coming this way. Okay, so now we can write the Newton's equations, and let me just draw a line here and then I get that for the x-axis, and for the x-axis, what do we get? We get that FEA cosine of 45 degrees plus FEB cosine of 45 degrees minus FDE, that is equal to 0. And remember, I know FDE from here. I know that force. And now I can write for the y-axis. For the y-axis, I get that FEA sine of 45 degrees minus FEB sine of 45 degrees minus 400, that is equal to 0. And then I can go ahead and solve for this, and I can solve here for these two forces, for this and this force, because I already know this. And when I do that, I get that FEA is equal to, I'm looking at my notes here, so FEA is equal to 636 newtons, and this one is in compression. And finally, FEB is equal to 70.7 newtons, and that one is in tension. Okay, so I have, let's just go back to the picture. So I have all this, right? So all I need is this one here. I need FAB. So for that, I'm going to work with join, with which join? Well, if I work with A, I would have to solve for these two reaction, which is a lot of work. Maybe I'll just work with this because I know these two forces and this force, so this is probably the easiest one to work with. So let's just do join B, and to do join B, let's just bring this down a little bit so we can see it here. So to do join B, which is this one here, the free body diagram for join B, what is that? Well, it would be just FBC. I know that one. Then I have here FBA. That's what I want. Then I'm going to have FDB. And I know this one, and I also know how it points because I know this one was a compression before, so it has to be a tension pushing on the joint. And finally, FEB. So FEB, and FEB points the other way. FEB points the other way. Okay, so now I can go ahead then and write the equations, and I don't need to write because I only need one of these. I only need this force member here, so I only need to write one equation. So I can write, say, I can write that for the x-axis I get FCV minus FBA uh, plus FEB cosine of 45 degrees minus FDB cosine of 45 degrees. That is equal to 0. And then I can solve for FBA, and I get that is 450 newtons, and that's going to be in tension. So this is the solution to the problem, and things to remember is that if you need a reaction, just start with one pin, solve for that reaction. Don't go ahead and solve for the whatever you don't know if you don't need. So you start solving for this reaction and then use this pin to find these two forces. Then use this pin to find these two forces. And then use this pin to find these two forces. And finally use this pin to find this force. The other thing that you need to be attention is that you're always drawing the free body diagrams on the pin. So therefore, if you add a force, here on C that points this way, that means the actual force on the member points the other way and it will be a compression. And when you use that force for this free body diagram here, that if you put the force pointing this way, then here it has to point the other way. Okay, so that's it for now. Let me know if you have any questions. Send me emails, and I'll do another video with problem 623, which is the one with the weight for the truss members. All right.